Let's talk about two preprocessor directives: include and define. Now, first question you might be asking yourself is, what the heck is a preprocessor directive? That sounds crazy. Um, there's stuff going on that you don't think about when you press your verify or your upload button. Both these things compile, but compiling, we're going to say it takes 3 steps. There's other stuff going on. But the first thing that happens, according to our simplified view, is the preprocessor part. So you tell the compiler what you want to do before it goes and tries to make things into machine code that the Arduino can run. So anything that's a preprocessor directive, anything you want it to do to your code before it tries to convert it into ones and zeros that the Arduino can read, starts with a hash symbol. And also it doesn't have a semicolon at the end. So they're only 1 line long. So we've got our include statement, which is including our library. It's very much like import statements in Java. So we've got some code somebody made to control servo motors, and we want to include it. Otherwise, our servo code here won't work, because by default, Arduino has no idea what a servo is. It has no idea what the attach function is. So we do need to include that. And what that does is kind of funny. So this is like before you go and compile it and make machine code, what it'll do is it'll go look for this servo.h file, this header file. Anything.h is a header file, which we'll talk more about later. It'll find it and it'll copy and paste it into your code. So pretend I'm the preprocessor directive. I'll be like, okay, where's this servo.h? Okay, I'm in Arduino. It's probably in libraries. Let's keep looking. Oh, here's servo. That's a likely place. Maybe in source files. And look, we got our servo.h, which just so happens to look like this. So here is the servo.h file, the thing you are importing into your code. And with that include statement, all of this junk just gets copied and pasted right where the include statement is in your file. I do that right now so you can see what it would look like, but it would just not be visually very effective for you. Anyway, so it's got a couple preprocessor directives of its own. Few, in fact. Everything with these hash signs is one, and then a couple other things going on. It's not too huge. Anyway, so that include statement just makes it all cut and paste right there. And then this define thing, it's like, hey, before you turn this into ones and zeros, I want you to look through my code for anywhere you see the word LED pin and replace that with 13. So it's basically a find and replace function. This whole define thing is really good because it's effectively you're making a constant. So we've done that before with constant int LED pin equals 13. By doing this with preprocessor directives, it takes no memory in the Arduino, because at no point does the Arduino ever come up with a variable called LED pin. It's LED pin is useful for me because I don't have to remember that the LED is connected to pin 13 and it's more readable in my code. But there's no reason that the Arduino needs some name called LED pin stored in its memory. So before we go and convert into code and send it to the Arduino, this just find and replaces everywhere there's LED pin and replaces it with 13. So if I'm the preprocessor directive before I'm compiling my program, I just go look for every place it says LED pin and replace it with 13. Oh, found it again. Replace it with 13. So yeah, we've got our include function, which goes and copies and finds the file that you put in here, and copies and pastes it into your code right where that include statement is. And then we got our define statement that's basically a find and replace and is a low memory version of making a constant int, pretty much. So hopefully these make sense. They're very, very useful. We use libraries all the time. And with the Arduino, they're pretty memory limited, so may as well do this instead of constant ints. Because if you're making bigger programs, the saved memory might come in handy. Anyway, I hope this made some sense and you find it useful in the future. Thanks for listening.